So, welcome back to Probably Optimal. In this video we will look at another probability puzzle, which is actually easier to solve than the last one, but it's tricky in the sense that your mind directly jumps to the wrong solution. The problem we are going to look at is the following. Assume that a couple has two children, and you observe that one of their children is a boy. What is the probability that the second child is also a boy? Before we will dive into the solution, let's have a look at a wrong kind of reasoning. So what we are looking for is the probability that both children are boys, given that one of them is a boy. And you might think that you can write that as the probability that the first kid is a boy times the conditional probability that the second kid is a boy given that the first kid is a boy, plus vice versa. So the probability that the second kid is a boy times the conditional probability that the first kid is a boy given that the second is a boy. And since these events are independent, you could simplify that to basically 2 times the probability that the first kid is a boy times the second kid is a boy, which, if you assume that it's equally likely to get a boy or a girl, it just evaluates to 1/2. But unfortunately, this kind of reasoning is simply wrong. Another way of reasoning that could lead you to conclude that the solution is 1/2 is to say that, okay, these two children are independent, so the conditional probability of the second child being a boy, given that the first child is a boy, is just the probability that the second child is a boy, which equates to 1/2. But also this kind of reasoning is wrong. So what do we have to do to get to the correct solution? And what is actually the correct solution? For this, just imagine the setup. So we have a couple, and we can assume that it's a happy couple because, they have 2 happy children. And since we know that they have 2 children, they are exactly 4 outcomes. First, they could have 2 girls. Second, they could have a girl and a boy. They could have a boy and a girl, or they could have 2 boys. But from the problem description, we already know that one of the children is a boy, so we can exclude the first case. So we have 3 remaining cases, and one of them is the one that is asked for. And from this we can see that the result is actually 1/3, because we have 3 equally likely cases, and one of them is the correct one. A bit more formally, we can write the probability to have 2 boys, given that one child is a boy, is the same as the probability of having 2 boys divided by the probability of having a girl and a boy, or a boy and a girl, or 2 boys. Since the latter ones are mutually exclusive, the probabilities just add up, and we get that this is the same as the probability of having 2 boys divided by the probability of having a girl and a boy, plus the probability of having a boy and a girl, plus the probability of having 2 boys. Since all these events are equally likely, this just equates to 1/3. And finally, if you are not convinced by this argument, then we can again do a little simulation study and try to estimate this probability empirically. So for this, we have our happy couple with their happy children to the left, and on the right we have a graph where on the x-axis we plot the number of trials, and on the y-axis we plot the current estimate, which is just the total number of times we observed 2 boys divided by the total number of times we observed at least 1 boy. So either a girl and a boy and a girl, or 2 boys. To make it a little bit more easier to follow, we will put a little frame around our happy family, and this frame will be colored in blue if there is 1 boy but not 2, it will be colored in red if there are 2 girls, and will be colored in green if there are 2 boys. Then, if we run this experiment for some time, we can see that while there is quite some variation in the beginning, because we have too few experiments performed, this empirical probability does indeed converge to 1/3. So that's it for the video. Let me know in the comments below if you also got fooled by your intuition, and thanks for watching.